Hello guys, today I am going to discuss about science class 10 chapter 1 chemical reactions and equations. So in this chapter, first of all, in previous class you have studied about chemical change and physical change. So chemical change is the one in which there is a change in chemical composition of some reactants. So there is change in chemical composition or evolution of gas, change in temperature. These are some characters of chemical reaction. So in chemical reaction, basically, it evolves. There are some things like evolution of gas, change in temperature, after that change in physical state. It can occur also. And change in chemical composition. So in this topic we will study about chemical reaction, which requires these some properties which is characteristics of chemical reaction. Also chemical reaction is somewhere it can be irreversible and somewhere it can be reversible. So I will give you example further. So now chemical reaction. So after this we have to cover chemical equation. So chemical equation is a equation to show about chemical reaction in a word or in a molecular formula. Example, we know that if carbon is burned with oxygen, it produces carbon dioxide and gives some heat. Oxygen. This is a chemical reaction in which we have used words for showing about the compound, molecular compound. And it can also be shown in the form of molecular formula. We C plus O2, it gives CO2 plus heat. So this is also a chemical equation. Now we will discuss about some additional information the chemical equation should give. Example, first of all, the chemical equation should give information of physical state of reactants and products. Now, what are reactants or the products? So in a chemical equation we seen earlier, you can see here that two things are required and one thing is releasing. So this is a reactant and this is product. So you can clearly see reactant and product here. On left hand side it will be reactant and on right hand side it will be product. So physical state, how will we solve physical state here? So suppose carbon is in solid state, so we will write here S. Oxygen is in gaseous state, so we will write here gaseous, and CO2 is also in gaseous state, so we will write here gas. Now somewhere also liquid is used, like H2 plus O2, it gives H2O. Here H2 is in liquid form, so it is liquid. It is gas form, it is also gaseous form. And sometimes aqueous solution also required, right? Like Fe plus CuSO4, it gives FeSO4 and Cu. Here Fe is solid, but CuSO4 is aqueous solution, so it will be shown by AQ. Here it is also found aqueous solution, and it is in solid form. So this is physical state denomination by S, AQ, G for gas, L for liquid, these things. So take a screenshot of this. I am proceeding. Now I will talk about how to balance a chemical equation. So balancing a chemical equation. How do we balance a chemical equation? Suppose previously I use a equation C plus O2, which gives CO2. Okay. Here you can clearly see that this equation is balanced. One carbon on left hand side, one carbon also on left hand side, two oxygen on left hand side, also two oxygen on the right hand side. So it is a balanced equation. But there are so many equations that are not balanced. Example H2 plus O2, it gives us H2O. You can clearly see here that this equation is not balanced. H2 on left side, O2 on left side, but here only one O on right side. So what will we do? We can clearly multiply by 2 here. H2, here is 2 oxygen, so we multiply by 2 here, and we will put 2 in the coefficient place. Not we cannot change the molecular formula. Cannot change molecular formula. Okay, so we will put 2 here. Now you can see that there are 4 hydrogen on right hand side, so we will multiply by 2 in hydrogen. So now you can see clearly that here is 4 hydrogen, here is 2 oxygen, here is 4 hydrogen, and here is 2 oxygen. So this equation is balanced. But this is very simple. Suppose there is some hard equation to balance. Example FeSO4 gives Fe2O3 plus SO2 plus SO3. Okay, it gives on heating. Okay, we will simply heat FeSO4 and it will give Fe2O3, SO2 and SO3. So in this equation you can clearly see that there are 1 Fe here, there is 2 Fe on the right hand side, 1 S on the left hand side, 2 S on RHS, 4 oxygen on LHS, and 6 to 8 oxygen on RHS. So what we can very easily do, you can clearly see that all atoms on right hand side is double of that of LHS. So you will clearly multiply 2 here. Now you can clearly see that all equation is balanced. So this is a balanced equation now. And one thing you should know that it is not necessary in all equation to show about physical state. We can clearly say that I am not showing here physical state. Physical state is not necessary. It is only used for additional equation, also additional information. Example, here I am giving heat. This is also additional information that after giving heat it can only decompose. Okay, so this is additional information. Somewhere sometimes we also use pressure required, temperature required, and catalyst required. Now this for what is catalyst? So catalyst, you can clearly see that catalyst is a word. So catalyst is a object or any metallic surface, or any object which increases the rate of reaction. So catalyst, what catalyst do? It increases the rate of reaction. Means if there is suppose there is a catalyst required named sodium here. Suppose that it is not required. So if FeSO4 this equation is going in this reaction is going on in 5 minutes. So by putting Na we can do this reaction in lesser minute, even in 10 seconds or 20 seconds. So this is a use of catalyst. Okay. So this the method which we previously read for balancing the equation was heat and trial method. For any shortcut method, we have to know about oxidation state. So there are also shortcut method by oxidation number by balancing. Oxidation number. Which we will study in next some lectures, not in this lecture. Now I am going to discuss here about types of chemical reaction. So there are the many types of chemical reaction. We will classify them. Number one is combination reaction. Number two is decomposition reaction. Number three is what? Displacement reaction. Number four is double displacement reaction. Number five is oxidation or reduction, which is collectively called what? It is collectively called redox reaction. Now we can also classify it on the basis of transfer of heat. On the basis of transfer of heat, there are two types: exothermic reaction and endothermic reaction. We will study about this one by one in the next lecture. So thank you guys for today for joining the lecture. Thanks.